ever going to map the entire world's oceans in just 5 years? Seabed 2030 is a global initiative to map the world's oceans. The area that lacks the most data is the Southern Ocean around Antarctica. Less than 23% of it is mapped reliably. Mapping the Southern Ocean is very challenging because of the extreme temperatures, high winds, sea ice, and remoteness. We even have more detailed maps of the Moon and Mars than we do of our own planet's oceans.
We want to map the ocean because it can help us understand climate change, weather patterns, discover new marine life, and make it safer and easier to navigate ships.
Most seafloor mapping is completed using sonar technology mounted on ships. Some mapping is completed by unmanned submersibles, but exploration is limited by battery power and accessibility.
Currently, us marine mammals are tagged with cameras and other sensors. The tags can connect to satellites because we come to the surface regularly to breathe. However, sonar equipment is dangerous for marine mammals, so ships must turn off sonar when close to us.
We found an article about sea lions with cameras attached, but this caused them to swim 19% slower and expend 6% more energy, which made them more susceptible to predators.
Elephant seals are the second deepest diving mammals, and we live in the Southern Ocean. Tracy Mercer, a seal expert, told us males are 20 feet long and have limited predators, so they could carry a larger device without being impacted.
Ryan Egan. We learn more about underwater exploration through documentaries, books, and a visit to the University of Delaware Coast Day. We discovered more about tagging underwater animals to a turtle expert and a shark expert.
Based on this research, we decided to have an autonomous drone attached to a male elephant seal that would detach and map the Southern Ocean floor.
Ryan Egan, a climatologist studying Antarctica, said this would save energy by not using the device's power to get to the seafloor.
Next, we interviewed Dr. Fadak, an elephant seal expert in Scotland. As a biologist, he explained there is a lot still unknown about us elephant seals. We've even been recorded as diving deeper than the expected ocean floor, changing what scientists thought they knew from sonar.
We thought about shifting our project to learning more about elephant seals, but then we met with Dr. Art Trembanis, a robotics mapping researcher, and he was very excited about a seal-deployed autonomous underwater vehicle, also known as an AUV, for the Southern Ocean, using animals as a stepping stone.
We then decided to have a combination device that would optimize the information gathering to learn more about elephant seals and map the ocean.
Our final device, the SealScope 360, is attached to a male elephant seal and is streamlined so it shouldn't impact the seal swimming. It has 3 main parts.
The first part, the base, is securely attached to the seal and holds the conductivity, temperature, and depth, or CTD, instruments, power source, GPS tracking chip, and winch. Attached to the base through the winch is the second part. It's torpedo-shaped with multiple cameras to see the seal's surroundings when the seal stops to rest or sleep, and is on a tether so it can be reeled in and out as needed.
The third part is a detachable drone that also has CTD instruments, GPS tracking, and sonar for mapping.
We interviewed a biomechanical engineer and learned about the benefits of an animal-shaped robot. It's more streamlined, designed for efficiency, and less frightening for sea life.
As we researched how AUVs withstand crushing pressures, we learned about research in China that uses silicone or soft plastics instead of metal frames. The electronics are spaced apart with padding, with the expectation that the device will compress.
Based on this research, we decided to have a stingray-shaped AUV made with soft materials. This will also make it lighter and more streamlined on the seal's back. Once the seal reaches a certain depth, the AUV will detach and glide near the ocean floor and use sonar for mapping, as well as taking CTD measurements. Once the battery becomes low, the AUV will surface and can be retrieved via GPS.
We shared our presentation and follow-up questions with almost all of the experts we interviewed. Tracy Mercer shared our presentation with her colleagues from NOAA, and she said that everyone was truly impressed. Dr. Trembanis described our idea as a cyborg marine mammal device like an Iron Man suit for a seal.
The SealScope 360 will allow us to maximize the data collected from one tagging to provide much-needed information about the Southern Ocean and elephant seals.
For our project plan, at the beginning of the season, we set goals and created a tracking spreadsheet. Every few weeks, we would review the list and chart our progress to create the SealScope 360. And thank you from Load Robotics.